Hello everyone, today we're going to discuss MATLAB Graphics. So MATLAB is a powerful tool in visualizing equations, statistical informations, and other uh, information that we can put into equations or into relationship between variables like in lines, curves, surfaces, among others. So one of the powerful tools of one of the power of MATLAB is its ability to sketch figures. So it can perform the following. It can graph ellipses, it can graph hyperbola, parabola, among others. So it can provide labels, the y-axis, the x-axis. So basically, everything that you can work on pen and paper, you can work on in MATLAB to visualize the results. So the first command that we will be discussing is the figure. So if you want to display or if you want to put a graphing window, or if you want to call the graphing window, you're just going to type figure. So let's see how we're going to do that. So what you're going to do is, so let's clear it first. You're just going to type figure, Figure. So if we're going to type figure, we're going to see this this graphing window here, um, this one. So we can see this graphing window figure. So figure one. If you're going to call it again, we will be having another figure or another graphing pane. So let's have 2D plotting. So when we're going to plot functions in MATLAB, what we're going to do is to call it using the plot command. So the plot function is used to produce two-dimensional curves using x and y data matrices specified by the user. So the command is plot and then your x data, y data, and then CLM. So C is for the color, L is for the line type, and M is for the marker. Now you can also have um, multiple lines by having x1, y1, color, line, style, and the marker for object 1. And then you have your x2, y2, and CLM2. So you can have the first graph over a certain interval and then another graph over a certain period. So this is used for 2D plotting. So for this figure, we plotted a blue line and then a green line. So first, let's have the x values. X is from 0 to 10. So it would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we evaluate y. So y is the line 2x plus 3. So every value of x, we're going to compute for the value or for the corresponding value of y. And then after that, we plot x and then y. So let's try to work on that. So we have x is equal to 0 to 10. Now let's not display the result anymore. So let's place semicolon. And then y is equal to 2 times x plus 3. So, and then after that, we have plot and then x comma y. So here, we're going to have an output, which is the graph of y is equal to 2x plus 3. Now we can have another graph. We can have another graph for y2. So y2 is equal to x plus 2. Now let's not display it anymore by placing semicolon at the end. So here we can have plot x and then y2. Let's have plot xy. So sorry, y yung nagamit ko for the first one. And then we have x and then y2. So here you can see that there are two graphs being shown here, two lines with different slopes and different intercepts. So, ayan. Now, in order for us to identify the points on the graph, we can visualize the graph by adding grids. So we have the command grid on. Grid on creates the grid on the current figure. So you're going to see these lines here by typing or by issuing grid on command. And then to turn off the grid, you can use grid off. Now to toggle from on and off, you can just type grid. So let's try to do that from the figure that we have. So we're just going to issue the grid command. So if we're going to type grid, then it toggles into the grid on. And if you're going to type grid again, so it toggles into grid off. But you can have grid on so that you can see the graph. Next is the choice for color, line style, and marker. So there are different colors, markers, and line styles available for you to choose from. So it should be a combination of one color type, one line style, and one marker for every graph. So you can use, say, for example, magenta, X marks, and then triangle. So you have your colors, your line styles, and then the different markers. So from the figure, so when you do your plotting, like in this case, we can choose a color. So say for example, magenta, and then the line style, I would be choosing a point, and then a hexagram. So that's for the first. While for the second, let's have another style. So say for example, let's have a red line with an asterisk or a star. And then for the marker, let's use a triangle up. And then let's close. So there is an invalid line style and color. Okay. So here, the resulting image would be like this one. So you have your um, magenta and then the red one with an asterisk and a dot as the markers. So you can choose from these different options for colors, for markers, and for the line styles. So it is a combination. So if you're going to graph your function or your line, you can choose from this set of colors. So another example, let's graph a red sine wave. So I would be closing the command first. So let's close this figure. Tapos let's issue the following commands. So x is equal to 0 with an interval of 0.1, and then the last value is 2 times pi. So we start with 0 with our increment 0.1, and then the last value is 2 pi. For y value, we have sine x, and then we're going to plot xy with the color red. So on our graph, you're going to see a sine wave from 0 to 2 pi. So this would be the appearance of the curve. Now what we are going to do is to issue grid on so that you can see the maximum point and the minimum point. Now there are some as a challenge, you can try to graph the following: 2 times cosine 3x. You can also try to explore the graph of exponential functions, logarithmic functions, inverse functions, trigonometric functions, hyperbolic functions, and other functions or algebraic functions based on their specified domain. So we need to identify the domain because we need to identify the range of values or the specific values where the function would exist. Now we can also um, graph multiple functions on a single plotting area by using hold on. So hold on holds the current plot, and holds off releases the hold to the current plot. So if we want to graph sine x, and then after that, we want to graph e to the negative x. So we must issue hold on so that this would not be replaced by the second one. So what MATLAB does is MATLAB replaces the original graph by the second graph if we're not going to issue hold on. So let's see how would that work. So let's just recall 0 to 2 pi. So x is 0 to 2 pi, and then after that, y is equal to sine x. And then plot xy with the color red. So we're now going to have this image, and then let's issue grid on. So we have grid on, and then after having grid on, what's next? Hold on, and then So we do hold on so that the new graph would not replace um, this sine function. Now, next thing to do is to do plot. With a given value of x, we're going to plot e to the negative x. And then we have the color blue with colon and then asterisk. So this is the graph of the exponential e to the negative x, the exponential function e to the negative x. So this is the graph of the function. Okay, let's now continue. So it is a sine wave, and then we hold on so that it would be able to graph e to the negative x. So there are other commands that we can use, but we can have this commands, or we can have it from the display tab. So I want you to observe what happens if we will be issuing some commands listed here, like so we have zoom on, zoom off. So if we have zoom on, what you can see, you can now zoom onto this figure. You can zoom in and zoom out to the figure. But if you have zoom off, so it would be locked on a specific image. So we can use our left click and right click and double click uh, to zoom out and zoom in the figure. So you can zoom in and zoom out. Now to put graphs, or to put annotations to the graph, so we can have, so this is the previous command that we have. Now what we're going to do now is um, to put labels, or to put annotations to the graph. So for this one, we're going to change the line width to 2. So let's try working with these commands, or issue this set of commands. So we start with clearing out the screen. So we have x is equal to 0 to 2 pi with an interval pi over 20. So 0 to 2 pi. And then y is equal to the sine of that, so sine x. And then we plot x and then y. Now I want blue, and then s, and then hyphen. Now take note that I want a line width of 2. So the graph of the function would be this one. So it would be a thicker curve. Next would be to issue hold on. So since we have still the hold on command issued, the e to the negative x is not removed from the graph. So next, y1 is equal to cosine of x. So we now plot x, y1. Now I need a red graph. So r greater than colon, and then this time I need a line width of 2. So we have a thicker line width. So let's just check the spelling of the commands I am issuing. So this is the graph of cosine x. So if we want to add title, you can, on the figure command or on the figure window, we can explore on adding text. So we are going to click on insert. So we can insert title and then sign function. Now we can also insert the x and y axis. So x label, so say for example we want it time, and then we can also insert y label, so say for example power. So we can have the graph of power with respect to time. So insert and then the x label, the y label, and then the title. So you can insert the title. You can uh, place some properties, the style, the title, so you can change the font size and the font type or the font to be used. Now, another way of placing title to the graph is using the command title and then graph the enclosed in a single quote the title that you're going to place. So say for example, graph of sine and cosine function. So by issuing that command, the graph of sine and cosine function would appear on the title bar. Now if we want to add legend, so the command would be legend and then sine function for the first graph and then cosine function for the second graph. And then for the X label, so this is what we have discussed earlier. So we insert, and then we insert the X label and then the Y label. Or you can have the command X label, X axis, font size, and then 60. So this is the name that you're going to place on the X label, and then the font size and the font style. So say for example, on the first graph, you have the sine function. So we can have the label y is equal to sine x, and then the text is this one. So text 3, 0.5, and then the string 1. So sine function. So for string 2, we have cosine function. Y is equal to cosine x. So this is what would appear. So you have placed the graph of y is equal to sine x and y is equal to cosine x. So let's try to do that. So we have the x values. So this is now the figure. Now let's put a label. So what we're going to do is to have string 1 is equal to sine function, so string 1 sine function, and then string 1 second element y1 equals sine x, and then text 3 0.5, and then the string 1. So observe that there is this label sine function and then y is equal to sine x. So nag-overwrite lang si exponential function. So we can have also string 2. So string 2 this time is cosine function. And string 2 is equal to y. So let's have y2 is equal to cosine x. And then string 2. So text 0.3. Let's negative 0.6. So this is, I think, the location of the text. So 3, negative 6. So x is 3, tapos y is negative 0.6. So the point is located, or the label is located at this coordinate, 3, negative zero point 0.6. And then you place the label y2 is equal to cosine x. So we can add annotations by clicking insert, x-axis, x label, and then y label. So here you can see that there is a legend sine x and cosine x. Now you can also save figures. So if you're going to use these figures on your, if you want to show this figure or save this figure, tapos ilalagay nyo siya as image to your documents, so you can download it and save as a picture file. So maybe it would be saved as a bitmap or a JPEG file. Now, if you want to graph multiple plots per frame, like in this case, so 2 by 2 siya. So this means that there are 2 rows, 2 columns. For this one, this is a 2 by 3. So 2 rows, 3 columns. So just identify the number of elements. So if you're going to issue 2 to 1, so 2 to 1, so it means that we are expecting 2 rows, 2 columns, 2 rows, 2 columns, 2 rows, 2 columns, 2 rows, 2 columns. So since we are expecting 2 rows, 2 columns, so the first row, so this is 1, 2, 3, 4. So 2 rows, 2 columns. And this is the first element. So you have 1, 2, 3, 4. For this one, this is a 2 row, 3 column. So 1, 2, 3, 4, 5, 6. So pwede ko siyang i-mix na ito yung first row ko, ito yung second row ko. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So try the following commands in the command window. So for this case, we're going to graph um, into different subplots. So clear screen. So first we have x is equal to 0 with an interval of pi over 20 up to 2 pi, because one cycle of sine and cosine is 2 pi. So let's have 2 pi as the domain of the function. So 0, pi over 20, 2 pi. And then y is equal to sine x. Now, we are going to plot this. We're going to divide the screen into a 1 row, 2 column. So 1 row, 2 columns. And then on the first, so we are dividing the screen into 1 row, 2 columns. So column 1, column 2. But we are going to call, or we're going to cite the first column. So ito siya, the first element. And then after that, we're going to have subplot. We're going to have plot xy. So we're going to plot now the sine function, and the color is blue. S hyphen and then line width is 2. I hope there's no error. Okay. So this is how the graph would look like. It is divided into 2 columns, 1 row, and the first element is this one. Now if we're going to call on the second command, so we evaluate y1, it is equal to cosine x. So subplot 1, 2, 2, and then plot x, y1. We want it red, greater than colon, line width 2. So we have plotted the two graphs into a single figure pane. So for the basic plotting commands, so if you want to graph commands easily, uh, EasyPlot is an easy to use function plotter for algebraic and transcendental functions, parametric equations, implicit and explicit functions. So EasyPlot. And then you just type in the plot of the function. By default, the domain is negative 2 pi to pi. So you can also specify your domain by placing it enclosed in a square bracket. Example, so here we have 6 figures. We're going to have a 2 by 3. So I would be closing the figure now, CLC, and then I close the figure. So we call on subplot 231, subplot 231. So we have the first plotting space. After that, we do EasyPlot. So that we can easily plot the function. So we use EasyPlot cosine of x. So this must be symbolic, symbolic variable. So we enclose it on a single quote. So EasyPlot cosine x. So you can see here your EasyPlot. Yeah. Now you can also define your symbolic variable x and y so that we can plot it directly. So for the next uh, figure, 2 rows, 3 columns, second element, we can now easy plot. We can now plot the function. So easy plot cosine x. This time I want the domain from 0 to pi. So this is the plot of cosine x from 0 to pi. Next, subplot 233. So for the third element, now this time it would be a more complicated function. So it is EasyPlot. Since I have defined the symbolic variable y, so I can now use it. So 1 over y minus ln. Ln is log plus log of negative 1 plus y plus x minus 1. So the third figure would look like this. Next, subplot 234. So for the next subplot, we're going to plot easy plot x squared plus y squared minus 4. So here you can see that x squared, you know that x squared plus y squared minus 4 must be a circle. So we can have it grid on. We can have format compact, format fit. Oh, sorry. axis equal, so that it would appear as a circle, and then we can also have the next uh, subplot 235. So for 235, we have x cubed plus y cubed minus 5 times x times y plus 1 over 5. Now we want to graph it from -3 to +3. So this is the graph of that function. And for the last subplot, 236, I want to graph the parametric equation sine t, but t is a parameter, and then cosine t. Again, t is a variable. I haven't defined t yet dun sa sims natin kanina. That is why I am enclosing it with a single quote. Sorry. Let's have it sine t and cosine t. So it is still a circle. This parametric equation is a circle. So this is the sample graph. Let us just verify if we obtain the same graph. So somewhat similar, except for the last, except for graph number 5. I think I have encoded a different function. So for polar curve, um, we can use polar. Instead of plot, we can use polar TR. So polar, so TR and then the domain. So T is the independent variable and R is the dependent variable. So I would be closing the figure, and then CLC T is equal to, I want a linearly spaced data from 0 to 2, 0 to 2 pi with 200 elements. So T is equal to lin space 0 to 2 pi, and then R is equal to sine of 2t dot asterisk cosine 2t. So R is equal to sine 2t cosine 2t. So if there are two functions of t, dapat lahat ng operations nyo would be replaced by dot operation. So dot asterisk, dot raised to. So if you have more than two operations, or more than two instance of that variable, so you use dot asterisk, dot raised to, and so on. And then we use polar t comma r. So this is the graph. of that polar curve. So we can place title, polar plot. So you have your label here, polar plot. So you can also perform statistical graphing, like, for instance, histogram. So histogram is a way of graphing your data. So as an example, let's have x is equal to negative 2.9, 0.2, up to 2.9, semicolon. Y is equal to the random number generator 5,000, comma 1. So we generate 5,000 points. And then histogram of y, comma x. So this is the histogram of the randomly this is the graph of that randomly generated numbers. So we can have title, histogram. Let's just name it as histogram. So you have your label histogram. So for pie chart, you have your data. So this is, for example, your data. So your data is an array of numbers: 0.5, 1, 1.6, 1.2, 0.8, and 2.1. So this would represent the slice on your pie. So what you can do here is, um, from this, we can have the pie chart of A. So this is the figure. This is how the values are distributed. So you have 14%, 7%, 29%, and so on. Now, what if we want to um, we want to pull out some elements? So let's have B is equal to the maximum of A. That's 2.1. So if we want to pull out this element, uh, what we can do is uh, we identify certain elements to explode. So, yung explode, ang gagawin niya dito would be, so when we do pie chart, pie A tapos explode, what it does is it pulls out the first value. So let's change the value of explode. Let's make it bigger. So 2 and then 1, 1. So if we're going to graph it again, so we pulled out certain elements. Okay? So here we use subplot so that you can we use subplot so that we can visualize the two graphs. Now for this one, you can see that the largest slice is being pulled out uh, by using this command. While for this one, it pulls out the first element because that is the element which is at a logic high, or is placed at value of 1. For bar graph, so you can have a matrix or an array. So for a single array, you can graph it. So or you can have an array Pareto comparison. So 5, 2, 1. So this is 5, 2, and 1. We can also have a 3D bar chart like in this case. So I want you to explore on the different plotting commands in statistics. So you can have an area, a pie, a rows, stairs, stem, quiver, compass, and feather. So for this one, I think we can use the data A. So you can have an area chart. So area, so this is how an area chart would look like. We can have a 3D pie chart. So pie 3A, rows A, among others. So you may wish on to try the different commands. So here you can see the different commands. So we can have plot, plot 3D, mesh, surf, EasyPlot, EasyMesh, EasySurf. So for 3D plotting, we can plot this in a 3D plot. So if you're going to issue this, so first you have your x-axis 0 to 2 pi. Now we are going to plot this in a three-dimensional plot. So your x and y should be ranging from 0 to 2 pi. So x and y would be a mesh of 0 to 2 pi. So you have your x and y's, and then you have subplot 2 to 1. Now we plot sine t and cosine t. axis equal. So this is a circle. This is the one that we have plotted earlier. While for this one, it is sine x plus cosine y. So this is a 3D plot. So try to pause the video and graph the following or encode the following commands in MATLAB. And this is what it would look like. So the first one is a circle. This is circle if you're going to issue axis equal. And then you have the multiple graphs of sine x plus cosine x and so on. So to easily graph this function, x to the fourth plus y cubed cosine x. So we can use EasyMesh. Mesh is net. So you can have the EasyMesh of this curve x to the fourth plus y cubed cosine y all over x squared plus 1 times y squared plus 1. So with this, you can identify the highest point, the maximum point, and the minimum point. So this might be a local maximum as well. So another graph. So ito naman, kapag surf, may kulay, may surface. Unlike for easy mesh, which is net. So for easy surf, it would be a surface. So it's a colored graph. So you can type easy surf and then the curve or the function. So how to use easy surf? So the command would just be easy surf and then the graph in 3D. So say for example, we have the paraboloid z is equal to x squared plus y squared. So easy surf x squared plus y squared. So if we want hyperboloid or parabolic hyperboloid, so easy surf x squared minus y squared. So easy mesh is a mesh. So it's a net type of curve. And for the other graphing functions, so we have mesh, contour, contour 3, waterfall, surf, and plot. So you can check on help command to check on how to use these plotting commands. So that's all for today. Um, thank you very much for listening, and please check your Blackboard regarding the announcements on what to do for this week's activity. So see you again next time. Bye bye everyone.